So first off, for those of you who aren't familiar with Meraki, what do we do? Well, Meraki builds cloud-connected networking and IoT devices that allow businesses to manage very small to extremely large networks from a single dashboard. This includes network devices such as firewalls, routers, switches, wireless access points, but also IoT devices like advanced cameras and environmental sensors like temperature sensors. The Meraki platform gives an IT professional the ability to manage the whole network with a single pane of glass and much, much, much more. And the technology stack behind this, the Meraki platform, is what I'm going to be talking about today. At Meraki, we really think of the cloud platform as a launch pad for new products. It supports our intelligence across our product lines, which is powered by one of the largest data sets in the industry. It also supports our APIs and ecosystem. It enables customers to automate, integrate, and also extend the platform for their own use cases. And so what we're really trying to build here is the most advanced cloud platform that allows customers of any scale. And we really look at the cloud platform as the foundation for both our API and ecosystem. It's basically what we build everything else on top of. Meraki has been in the cloud managed networking and IoT space for a long time now, being founded in 2006. In that time, we've experienced a tremendous amount of growth, and that growth has taught us a lot about where we needed to make investments and where we needed to evolve. Here's some things we started to observe early in our growth. Not only was the number of customers growing, the size of our customers continued to get larger and larger. We had demand for products all over the world, and we saw countries that were starting to become more and more strict about data sovereignty and compliance. We were also seeing exponential growth in the number of devices. We were also seeing exponential growth of the number of devices connected to our customer networks as well. And here's some numbers to kind of give you a sense for what we've grown by in that time. We have over 650,000 customers across 190 different countries. This means we have really tiny deployments from your mom and pop shops out there all the way up to large enterprises and retail companies. I'm confident that you're aware of some of these, and some of you may have gotten your morning coffee from one of these businesses. The footprint that these customers have continues to get larger and larger. We have 10 million devices now and growing, with over 120 million devices connected to those networks. To give you a kind of a rough scale of the growth, when I joined Meraki 2 years ago, just under 2 years ago, we were at around 7.5 million Meraki devices out there in the wild. Not only that, we see billions of API requests to our dashboard, with over 100,000 monthly active API account users and hundreds of official partners in our ecosystem. None of these things would have been possible if we didn't evolve our platform, nor will it be possible for us to scale our platform over the next stage of our growth without continuing to evolve. So why evolve the cloud platform architecture? I just sort of spent the last couple minutes here talking about the sheer scale of our customer base. But our reasons for evolving our architecture weren't just because of scale. It went beyond that. Combined with the growth, we also have a goal to be the most simple, secure, and intelligent networking and IoT platform for organizations everywhere. In order to accomplish the growth and our goal, we had to evolve in 4 key areas, which was our agility, reliability, scalability, and security. From an agility standpoint, we want to increase the velocity which we were delivering new features and functionality to our customers. We also needed to meet our customers where they were and change to meet the demands of our customers. From a reliability standpoint, our platform has been and continues to be something our customers depend on to run their business, and our reliability needs to be kept at a really high level. And from a scalability standpoint, I just spoke about our growth, but we know that our business is continuing to scale exponentially, and our backend infrastructure needs to be able to easily handle that huge device growth. In order to deliver on those features and build reliability, we need to scale our development teams. And you need a lot of engineers to accomplish what we're setting out to do. And how you develop applications and your platforms with 100 engineers is a lot different from how you develop and run an environment with 1,000 engineers or 2,000 engineers. And from a security standpoint, the security landscape is as dynamic as we all know. And we need to be able to provide an extremely secure platform that changes with the environment that we live in today. One thing to keep in mind is that the plane was already in the air, so to speak. We already had thousands of customers and we had millions of devices out there. And while we needed to evolve, we needed to be extremely thoughtful about how we made this transition. The first area that saw a lot of change in our adoption was the adoption of microservices and containers in our environment. This is a diagram by Martin Fowler that describes when you should start to use microservices. Many of you may have seen this graph before. One of the first decisions we made some time ago was to embrace more microservices into our architecture. Looking at the graph here, as the complexity of a monolith, as the complexity of a monolith increases, the productivity decreases, and that's where we were feeling some pain. A monolith starts to reach a point where the code becomes so large and complex that it becomes hard to be agile. When Meraki was starting off, it really didn't make sense to have the overhead of a microservice architecture. But as the complexity of the dashboard application increased, it started to make a lot more sense. So why microservices? It turns out they do a good job of addressing our high-level goals around the things we wanted to improve and evolve. We wanted to be able to move even more quickly. We were already deploying several times a day, but we wanted to go faster. We wanted teams to own services and have control over them, giving them the autonomy to innovate and deliver faster. We wanted stability and security to be easier, and scalability to be easier. One thing I want to call out here is that balancing and sizing of microservices is important. You can really go off the deep end when and create problems for yourself and your architecture and your team if you aren't thoughtful about how you introduce microservices into your infrastructure. Many of you have experience with things probably like dependency hell and technology sprawl that ends up actually slowing you down when your intention was to speed yourself up. And again, you have to remember, we were running a really critical business already. So we started to introduce them where it made sense. And furthermore, to start moving towards this architecture with more microservices, we needed a nice, simple, and consistent way to package and deploy our services. This is where containers came in. We looked to containers as a foundational building block for this transition. A container consists of an entire runtime environment. So the application, all its dependencies, libraries, binaries, config files, etc. Bundled all into one type package. By containerizing the application platform and its dependencies, differences in things like your OS distributions, underlying infrastructure are really abstracted away. So you no longer care about what version of a library another service is running. You don't care what version of a framework another service is running. You can even control how much memory and CPU a container gets. So if you can create a container, it really makes it convenient to deploy it anywhere. This abstraction and isolation of concerns really helps with things like patching, for example, because you can really be targeted with your testing and your rollout. It facilitates experimentation. So things like rolling out multiple containers that are isolated from each other's with different sort of code paths that you could test with. From an ownership and autonomy perspective, you can really start to draw distinct lines with microservices and containers, and it allows these teams to function and develop independently. Next, I'll dive into a particular use case at Meraki. This is an oversimplified diagram of what our dashboard application looked like a number of years ago. You have a couple of databases, one is Postgres, and then you have a time series database. The main monolithic Rails application is there in the middle, and then there are a number of other C++ and Scala applications running on these Linux servers. This is one of the first steps we took. We started by containerizing the Rails application into several server services running in their own server modes on our application stack. We did this because it would allow us to experiment without affecting production services. So now we could deploy a new server mode silently and test without fear of breaking other critical production containers. We could upgrade any one of these containers independently. We could patch security holes faster. And we can really limit the blast radius, improving our reliability. And so if we go back and look at some of the things we want to improve here, from an agility standpoint, microservices really allowed us to experiment more and iterate faster. From a reliability standpoint, this limiting of the blast radius really helped us iterate faster while maintaining our high level of availability. From a scalability perspective, we were able to scale up the development lifecycle. And so engineers could move faster without worrying about what everyone else was going on in an engineering organization with hundreds of engineers. And from a security standpoint, we were able to do things like patch security issues faster and limit the testing scope to really, and limit the blast radius, which also helped us with security.
So where is Meraki in this state of transition again from monolithic to microservices?
Yeah, so we're taking our dashboard platform in many ways is still there, but we have containerized and added a number of services over the past few years. And so there are some global services that I'll actually mention here in a few moments, some examples. But there our next generation cloud connectivity platform, which I'll mention here in a moment, is based off of this new microservice architecture. And we're continuing to transition over. We're being thoughtful here. There are a number of reasons to maintain some of the components of what we had before, because they make a lot of sense and provide us a lot of value. For example, limiting blast radius in a sharded architecture, and has helped us move quickly. I'll jump into a couple of additional services, but I think there are, in our transition, we're still at the beginning stages, but if I were to give you a number, we're 10 to 20% transition. And that's by design. Our intention is not to go and just blow up the monolith and into a million different pieces, because there really isn't a need to at this point. Because it doesn't, our ultimate goal here is to deliver value to our customers, and that doesn't necessarily do that.
Great, thank you.
So just to continue along that line with maybe a separate branch to that, is Meraki in public cloud somewhere, or is this Cisco's own cloud as you're transitioning from monolithic to microservices? Can you even share that? I don't know.
Hold that thought. In about 10 minutes, I'll cover just that. The answer, the short answer to that question is we are in the public cloud as well. So jumping back in here. So now that we've started to containerize services, we can start to think about the natural progression into Kubernetes, which is a new platform we added to our technology stack. I'm sure most of you here, or all of you here, are aware of what Kubernetes is. But for those of you who are out there that aren't, it's an open source container orchestration system for automating software deployment, scaling, and management. It's something that can be run in your own data centers or in the public cloud as well. What we did was that we added it alongside our cloud platform to complement it. What this unlocked for us was the ability to launch global services that we could scale then independently of our dashboard application in a Kubernetes cluster and have it connect back via APIs in either direction. So as most of you know, you don't just stand up a Kubernetes cluster, deploy your application, and call it a day. There's a lot of things that go into running a robust Kubernetes platform that is production grade. Adding a system like Kubernetes to infrastructure means not only involving the application itself, it also means evolving the ecosystem around it. So from an infrastructure standpoint, there's a number of things you have to do to your network to handle and ensure that a cluster runs the way it should from a security standpoint and just from an optimization standpoint. You also have to think about how you're configuring a cluster. And we did this via Terraform automation. From a developer experience and application development standpoint, you really have to think about CI/CD tooling, GitLab for testing, and Jenkins and TeamCity. These are all tools we've used to enhance the developer experience when we're using a tool like Kubernetes. From a security standpoint, again, you can probably go up into AWS or maybe even in your own data centers and bring up a cluster relatively quickly, but you still have to secure it. And so we have something called the Meraki Secure Development Lifecycle, where we work with our security organization to ensure we're hardening and securing our infrastructure the right way. You have to think about things like hardening. CI's benchmarks is just one of the many sort of benchmarking standards that we looked at when we looked to hardening our systems. That's a picture of a container scanning device, but we got to ensure that the containers that you're deploying into your infrastructure are secure and are the right version and all of these things. And then also from an observability standpoint, you have to think about SLOs and SLIs about this environment. And for that, you need metrics, you need logging infrastructure. And these are all things that we had on one level in the environment already, but we had to then take it to the next level, and so that we could handle services running in Kubernetes infrastructure. As I mentioned earlier, one of the key aspects of the Meraki ecosystem is that the network and IoT devices are cloud connected. This is how the devices are configured and monitored, et cetera. Now, the devices can obviously be disconnected from the cloud, but if you want to monitor them, configure them, they need to be connected. And so it makes it incredibly important for them to be connected to our cloud. What's pictured here is our previous generation of cloud connectivity services. This worked by our previous generation of networking connectivity worked by initiating a secure tunnel connection from an agent running on the client, which is the device, to an agent running on the dashboard platform, then pushing encapsulated packets from the dashboard platform back to the device inside that tunnel. We embarked on rebuilding the service a number of years ago because it needed to evolve to meet the needs of our customer base. So as we started to work with larger customers, it became evident that we needed to simplify how our devices connect to our platform. This means things like standardized ports and protocols. We also wanted to use the latest and greatest security tooling to secure those connections. Also, because the size of our largest customers was increasing and the size of our overall node count was increasing, we needed a solution that would scale very easily and dynamically. Also, because we were changing such a critical part of our infrastructure, we wanted to move it into its own service so we could limit the blast radius and transition to the new service at a rate that was safe and measured. And so we use Kubernetes as a critical piece of the infrastructure for this new next generation connectivity service.
So like the reason you're doing this, like the reasons to do it are obvious. Like, is Meraki already running into problems, so you're trying to fix stuff and move forward, or this is forward looking and you're making these changes to prevent scalability problems?
This is absolutely forward looking. And so some of our organizations are getting into the hundreds of thousands of devices. And what we had before still works for those customers, but if we think about the next 100,000 or 200,000 or 300,000 node customer, we have to be ready for that. And as you can imagine, something as critical as this takes time and care and is incredibly risky in the grand scheme of things. You have to do this carefully and roll this out and be thoughtful. And so we're looking ahead here.
Perfect.
And this is sort of what we ended up building. This is, again, an oversimplified diagram here, but you'll notice a few things here. You'll notice that the new service is running as its own microservice in a Kubernetes cluster. You'll notice that we introduced Golang, which was new for Meraki at the time. for its and we introduced this for its performance characteristics. You also notice that both the new and old service are running at the same time, so we could do a slow and safe migration. You'll notice the node connectivity service in the box on the left. And we rolled all of this out using GitLab CI/CD pipelines and using Terraform to build the infrastructure in an automated way. So by adding Kubernetes, we hit these points again. From an agility standpoint, this team was really able to be autonomous and iterate very quickly. A lot of it was greenfield and was largely independent of the existing services. So we could provision as many of environments as we needed using automation tooling. And it allowed this team to do things like performance testing on a really wide scale. And we use this tooling today. And it actually unlocked this ability for a lot of other services in the future. From a scalability and reliability standpoint, this was now a service that we could not only scale up as needed, and we could do this dynamically, it was more reliable because of some of the self-healing properties of Kubernetes, and we could do a lot of that independent load testing that I mentioned. And we spent a lot of time locking this down, working with our security team to ensure we're following all the best practices, doing pen testing and whatnot for the environment.
I have a question kind of related to this idea of the evolution of this architecture, because I know that one of the questions that I've heard from people kind of in the background is around the dashboard architecture and its flexibility, I guess would be a polite way to put it, in the fact that, it needs to develop and it needs to progress. By doing this, will that give you the capability to modernize and refresh that architecture on a more regular basis to kind of meet customer needs? Because I know that there's been times in the past that it really kind of felt like you were shoehorning some things into the dashboard because that was the framework that you had to work with. Will this give you the extensibility to kind of to make big changes without disrupting people?
Absolutely, and that's really the intent of this evolution, is to really free ourselves and give us tools that allow us to not try to shoehorn things into the old infrastructure. And so as we think about the evolution, we start to think about global services, for example, that allow us to take advantage of these modern technologies, and it allows us to use newer technologies that we didn't have available to us because we were using a Rails app and we're using a single sharded node. Like this broadens the scope of tooling that we can use for any kind of new feature sets and data analytics. So jumping into the hybrid cloud next. Somebody asked the question about this just a moment ago. The last thing I'll talk about here today is with regards to our evolution and embracing the public cloud as a complement to our data center infrastructure. So if you think back to around 2006, 2007, when Meraki was founded, AWS was just coming into existence, sort of barely, obviously with a much limited feature set. Things like Azure and GCP weren't even really existing yet at that point. And so at that time, we had to build data centers and run everything out of them. That's what you did as a technology company up to the point that I'm talking about here. But as those public cloud platforms matured, they became a viable replacement for some of the types of workloads we needed to run and wanted to run. And so for years now, we've been embracing the public cloud more and more, and we're going to continue to do this going forward. And there's a number of reasons why. Our customer base is constantly expanding, and this means we have to meet them where they are, because there's a few things that we're seeing as trends, and as you all probably are seeing. Data sovereignty and compliance are becoming more and more critical piece of running a global platform. Things like latency obviously matter when it comes to networking. But we also wanted to take advantage of some of the features that the public cloud provides. We can spin up new infrastructure anywhere in the world. DCs can take a really long time, for example. And we all have heard about supply chain issues as well. And so AWS unlocks a lot of these things that we wanted to do. We also wanted to be able to spin up an arbitrary number of testing environments to do rapid testing and iteration. We also wanted to take advantage of a lot of the tools and platforms public cloud providers have built. But again, and this is where we have really started to lean into the public cloud like AWS. So now going to the console and spinning up a few instances in AWS is trivial. All of us have done it. It'll take you a couple seconds. The really important and challenging work is how you integrate this with your existing platform. Remember, the plane, again, is in the air. From an infrastructure standpoint, very similar to Kubernetes, you have to think about networking. How are you connecting the public cloud to your data centers? How are you transferring data around? How are you securing these networks? From an automation standpoint, again, how are you building the infrastructure in AWS? We chose to use tooling like Terraform to automate that. How do you now adapt your config management platform like Ansible to deploying things into AWS? You also have to think about inventory. This is something really critical in the compliance world. And we all know that you have to manage your costs in the public cloud because costs can get out of control if you're not thoughtful about how you're deploying things there. From a developer experience and application development perspective, you also, again, need to think about CI/CD tooling and testing. And from a security standpoint, you have to, we go through the same extensive process of hardening our networks and our infrastructure there. So again, we put them through MSDL, which is our Meraki Secure Development Lifecycle. We do the same sort of hardening and network scanning in these environments. And then again, now you have another thing in the AWS infrastructure you have to monitor. And so things like SLOs and SLIs matter, metrics matter, and you have to have your logging platform be able to integrate with all the tooling that you have in AWS as well. So one great example of how we're leveraging the public cloud is in our data-powered products. We collect a huge amount of data from our application our dashboard application. And we wanted to use that data to give our customers useful features that help them manage their networks and their devices more efficiently and effectively. In order to do that, you need to get your data to a place where it can be aggregated, cleansed, and analyzed. We did this by leveraging the public cloud and utilizing Kafka as a message bus for transporting data reliably. What you'll see in the diagram is data being sent to Kafka clusters in AWS VPCs around the world on top, with data centers there on the bottom. So the data gets sent and transferred up to VPCs all over the world, again, trying to keep that data local to where that data and the customers reside. And then performing analytics, data science teams slicing, dicing that data, and then generating models that can be sent back down to our data centers for utilization and new features. Now, the public cloud gives us this elasticity scale up to billions and billions of data points, and that's why we chose to put it there. We also chose to put this infrastructure in AWS because it would have been really hard in our data centers to build out this infrastructure from a cold start, and it would have taken a long time. And using the public cloud, we were able to use tools like S3 and EKS and Redshift, et cetera, and Kafka tools in the AWS ecosystem to create those models. And so it really accelerated our ability to deliver on new infrastructure and services.
Curious, what's the timeline for this? I mean, is it rolling out to customers now, or is this future state, or what's the transition going to look like?
I can't speak to the timelines just yet, but this infrastructure is in place now. It is the data, and it has been for probably more than 6 months now. And so the infrastructure is there. Our data science teams are using this data to look at our customer patterns and generate models. I can definitely check back in with our product management team to see when a lot of these things will be delivered. My understanding is some of these things are already being delivered today. So the hybrid cloud then enables to have the agility to deliver features quickly, but also allows us to be closer to our customers for data sovereignty and compliance purposes. It also allows us to scale up our development practice by giving us the ability to automatically spin up a number of environments. And we're going to continue to lean more on public cloud for not only the purpose that I mentioned here, but also in running more of our critical workloads in the future, like our next generation cloud connectivity tools, or data analytics tools, or possibly even our dashboard application in the future.
Is it just AWS that you're going to, or you're looking at some of the other cloud providers as well?
We are looking at all the other providers, and in fact, we do use. I didn't get into in this talk, but we do use Azure and GCP for some of our other tools and services out there. Furthermore, as we all know, AWS is the most well-known. It's been around the longest, and so engineers are more familiar with it. But our intention is to be sort of cloud agnostic. AWS isn't in every country in the world, and we have to. We're trying to avoid sort of the vendor lock-in here, and so we're looking across all cloud providers.
Every time we see a public cloud outage, it seems that it exposes dependencies which are dependent upon dependencies upon other dependencies. How do you account for that? I mean, it's pretty much SRE fundamentals, right? But how do you proactively determine the scope of an outage so that you don't have to wait till one occurs to determine?
Yeah, I mean, there's a number of ways you can do this, but there are things that you can practice. For example, you can chaos engineering is a whole area of development these days, and that's something we do and plan to do more and more. We fail over our data centers often. We fail between the public cloud and not, and so there's layers to this, right? So we have to develop our application to be able to handle those types of outages and intermittent blips in networks and other issues. From an infrastructure standpoint, we have to build our networks to be fault tolerant. And then you also have to integrate with AWS in a way that you can, for example, handle a regional outage and be able to fail over very quickly or automatically into a region that isn't having an issue. And so there's, you have to design for it, but you also have to test it often to ensure that it's all working. In an environment like Meraki and any large company where you have tons of different services and customers all over the place, you really have to be religious about testing and automating and monitoring failure scenarios.
Gotcha. Now, the original Meraki data centers, are they considered legacy infrastructure to be migrated off of, or is that part of the long-term strategy to be hybrid between those data centers and public cloud?
The long-term strategy now is to have both be a critical part of infrastructure. So if I could imagine, like our vision here is that we'd be able to sort of turn the knob, so to speak. If we wanted to shift workloads between the public cloud and private cloud, we'd be able to do that. There are some customers that have sort of preferences when it comes to where their services are hosted, and AWS or GCP or Azure may not actually be where they want it to host for any number of reasons: legal, contractual, and it might not even be an option for them because it doesn't exist in their country. And so we're working towards building an infrastructure where we can move things in and out of different cloud providers and our data centers. Cool. The last thing I will do is bring us back to this initial one of the initial slides I showed here. The cloud platform really is our foundation, and it's come a long way even in the short time I've been here at Meraki. And what I've talked about today is really just a really small piece and a small peek behind the curtain of what we're working on today. A cloud platform is actively evolved as we speak, and I'm really excited for the potential it has to unlock for not only for Meraki but for our customers, more importantly, in the future.
It sounds like that this is a push model, that your customer base will be slowly migrated over to this new microservices architecture. And I understand that there are definitely reasons for that. But is there like a big, bright magic button that I can press to say, bring me to the new stuff? Because I know that I was involved with another company that was doing that migration work in the past. It was a huge UI change, which is the reason why it was kind of a pull model. But, you know, because there's a lot of things in here that are really appealing to me. Maybe they're not things I can necessarily access today, but like, let's say I want to jump in and use that. Can I just, like, I don't know, make a wish to get on it? Or is it just something that's going to happen magically one day?
I wouldn't characterize it as like this big flip over that's going to happen. The evolution is happening within the infrastructure as it exists today. And so if we're doing our job right, you won't notice a thing. However, what you will notice and maybe be able to opt into in the future is features and new UI designs, and that might be something that you can toggle between. And that's something that we could, I'm sure somebody on our UX team can and our product team can dive into. But from an infrastructure standpoint, there is no old infrastructure and new infrastructure. We like what you may do is move parts like services over. So I'll use the next gen cloud connectivity service as an example. Both are running. You can transition from one to the other via a firmware upgrade, but it's not like a big button you push and all the things that you were running in the old way is going to be running in the new way. That's not our intention. A lot of this is to upgrade and evolve components of this infrastructure. And from like, if you think of it as like almost like a feature flagging sort of kind of process, you as a customer would potentially be able to move from one kind of experience to another. That would be more like what we would do versus like a button that says, I want, like, for example, with my Outlook, like I want to use new Outlook now, and everything just changes all at once. That's not how we're thinking about it now, at least from a cloud platform perspective.